Bit about me, I've got 4 kids and 2 dogs. So profiling life is very important. But unfortunately, it doesn't seem like anyone's made like a dev tools for life. If you have, or if that's your business idea, let me know. I'll be one of your beta testers. But in my professional capacity, I work at AG Grid. And we've got both AG Grid and AG Charts now. So these are React components you can drop into your application, and everything's batteries included. You've got your grid, throw your data in, you've got your charts, and you can produce these beautiful visualizations with very little effort at all. So if you want to know more about that, come and speak to us at the booth. But I know why you're really here is to talk about profiling. So this is going to be, or this was the content of my talk until a few weeks ago. So I'm going to start with the React Dev Tools. We're going to look at the Web Vitals extension, Dev Tools Performance Panel in Chrome, and then I'm going to throw some quick fire hints at you from things that I've learned while profiling AG Grid. But as I said, this was the talk, and then Chrome made a big update where they deprecated the Web Vitals extension and they've moved this into the Performance Panel, and it's now called the Real-Time Metrics View. So this is a really quite exciting change because it's bringing all this features and usability that I think was underrated and underused in the Web Vitals extension directly into your Performance Panel. And hopefully you'll see by the end of this talk just how valuable that information can be for you. So first of all, the React Dev Tools. Now this says it's been downloaded 4 million times. So I'm guessing pretty much everyone here has got it downloaded. Yeah, it's good. As many of you who have downloaded it using it? A little bit more quiet. So yeah, so once you've installed the extension, you'll have this profiler and also a components option in your DevTools. So you can find it in there. You might run into this issue initially, saying profiling is not supported. So make sure your version of React is recent enough, and also that you're in development mode, because you can't profile against production, because this profiling inside of React, it adds extra, I guess, delays and work. So React strips it out in production so that your apps are as fast as possible. So you're either going to be developing against React development mode, which you have to remember does additional checks, but then React does also have this dot profiling version of the code as well. So it doesn't do all the dev checks, but it still has the profiler to give you the information. But once you've done that and it's working, you can record a profile. So here on this beta version of AG Grid, I was doing some performance testing on dragging columns and resizing them. So I recorded the profile, did my action, and then here we have this profile. So we can look through the different frames. So each one of these bars, all 254 of them, are individual renders. And we can go down and we can start interacting with this flame chart and click on these individual things and see, okay, which component is it? And also, this is going too fast. Let's slow it down, or I won't. I'll come back to it in a bit. And it can then drill into that and say, okay, from this component, which hook is causing this to render a lot? So what you maybe saw here, or maybe it didn't catch up with, is the thing to take away from this profile was there's a lot of rendering happening while we're resizing these columns. And then we can go down into that flame chart and it gives us the component names, and we can click on it and it will say, well, hook 30 changed. And then once you've clicked on the component, you can actually click from the profile to the components, I guess, tab in your DevTools, and then look down the list of all the hooks. And for us, number 30 is this state width. So it's a very quick way that it's enabled us to pin down to the exact state hook that is causing our component to re-render. So then we can dive into that code and we'll see something like this. We were using the width property, which was being updated to then change the style on this div element. And so every time the style was changing, as we were dragging things around, React was re-rendering all of these cells. And so that was the 254 kind of events that were being fired. So we can actually make these change, and this is the topic of a whole nother talk. We can just actually change this style directly. We're not changing any of the structure of React. We're just pinpointing this DOM element and saying, actually, we're going to take care of the styling, and we're just going to tweak the width. We don't need everything to re-render. We're just going to change it. And the result of that is now in AsiaGrid, when you're resizing columns, there is no re-rendering. So here there's 2 renders here instead of the 254. So you're getting a much smoother, much more like kind of native experience with these moving of the columns. And this was all very easy to diagnose via the React DevTools. And these are some important settings which you need to enable to give you this useful information. So in the profiler, you can say record why each component re-rendered while profiling. That's not on by default, I don't think. So if you turn that on, it then gives you that information of actually it was hook 30 that caused this component to re-render. So this is really key information. And then also there's this other bit under the components panel which says, parse the hook names. So instead of on the left where you just have these states and their values, you actually get the name. So again, this is just going to make you much more productive in being able to say, okay, it was this hook, and then this is actually the one in my code that I know I need to look at. And then also another useful thing, I think we've seen it in some of the talks before, is even if you're not profiling, you can enable this flag to highlight the updates. And again, we could see it here. We start dragging the columns and you can see all these cells re-rendering. So it gives us, I guess, a quicker way of just interacting with our app and seeing all the things that are changing. So I thought this was a useful video if you want to kind of watch it in your own time. And there's quite a lot of videos out there. I think this one has a good mix of content. And also he dives into the different formats of the charts that you can use within the React DevTools. So I'd recommend watching that one for a little bit more of a slow-paced talk. Because another thing that I want to cover is core web vitals. So these are metrics which are really important for your application, especially if you're looking to improve your SEO, your result in search, because it's kind of how Google will rank your website. So it's really important that we do metrics for that motivation, but also it gives your users a better experience. So you've got benefits in that sense that people will want to come back and use your site. And the one I'm going to focus on is interaction to next pane. So this is new as of March this year, and it observes the latency between when a user interacts with your site and when they actually get some visual feedback. So it's not necessarily that your site, can, or for us as AsiaGrid, it's not that the grid will filter all the data really quickly. It's more that if the user is typing something to trigger that filtering, they'll see all the filtering, they're typing, and it won't be like jumpy because the grid's getting in the way of that browser being able to re-render. And this is something which, React concurrency and all those concurrent features are able to really help you do and improve. So as I was going to say, the Web Vitals extension was a really good way of viewing this information, but it's been deprecated. So, and I think it's an important thing to notice here. This has only been downloaded about 100,000 times compared to the 4 million times, or was it even more than 4 million, but the React DevTools have been downloaded. So it's clear that the information here just isn't reaching the wide audience that it could do. So that's why I think it's really exciting that in Chrome version 129, a lot of this information is moving directly into your performance panel in what they're calling real-time metrics view. So in this, we'll see, I'll open up a profile in a bit, but it's giving you the same information. And also there's some really useful ways that it can compare it to your field data if your website meets the criteria for the Crux database. And also then it can tell you, well, actually, your development machine, your interaction to next pane might be really good. But compared to what we're seeing as real life traffic on your website, it's very different. So maybe then you should go and enable some of these throttling settings so you can slow down your network, slow down your CPU, and then rerun your tests and see what real users might be experiencing on your website. So this is an example which would work in the performance panel, but this is using the Web Vitals extension. So when I was testing this on our website and typing into this quick filter. So the quick filter then passed that text off the grid to filter, I think in this case it was 100,000 rows. And what the Web Vitals extension, and also what you'll see in the interactions list in your performance panel, is you'll start getting these red interactions saying, well, actually the time between the user typing and them seeing the browser repaint is too long. And so you're not having to profile or anything. You can just open this up, start interacting with your website, and see whenever this goes red. So what was happening here is that the quick filter text was being passed directly into the grid. And so every time that the quick filter text changed, the grid was then refiltering everything. So what we can do is we can just defer this filter text. We use the use deferred value hook, and then what this hook is going to do is say, well, actually, this value, it's not critical that it updates immediately and synchronously. Actually, what I want you to do is make sure that the browser has the possibility to update and re-render. And while we're yielding to the browser to do that, just wait with this deferred value, the last one, until the browser is finished doing its work, and then you can get on with your filtering. And so if we make that simple change, we can now see, we can type into this filter box, we're seeing every single key press, and we're just getting logs of green interactions to next paint. So that's how you can use those metrics to interact with your site and see where things are that you need to improve. And once you've done that, or you've worked at that level, sometimes we need to go even deeper. And that is the phrase of the conference, isn't it? Let's go deep. So the Chrome DevTools performance panel, when you start recording these profiles, this is when you really can go deep. You can find individual methods that are taking longer than you expected, or you can start getting into the world of forced layouts and CSS and all these kind of thrashing issues that you might find. So this is something which I've done for EduGrid as well. So here I'm profiling the performance of our scrolling. And the grid here is the vanilla JS one. So I've recorded the profile, and then we get this table. And what we're actually going to do is dive into this together. So you can save profiles in once you've recorded them, and then load them and share them. So we've got this view. So this was the result of creating a profile while we were scrolling. And what we can do is we can zoom in here to a particular section, and we can see we've got all these different tasks. And what I'd like to do is come down here to this bottom-up panel, because what this enables us to do is quickly see, well, based on this self-time, this is the place where most of the time is being spent while we're rendering. So you've got total time and self-time. Total time is, say, your method ends up calling down in a call stack to some other component. That takes a long time. So the total time at that top level will include all the time of the children methods. But that's not quite so useful because the time isn't spent in that top level. You want to know where is the function that is actually taking all this time. And so that's what self-time gives you. And what we can see here is that actually it's this parse HTML is taking up about 34% of our rendering time. And now we can start drilling into this. Maybe I'll make it a bit bigger for you. And we can drill in and say, well, it's coming from set in the HTML, which is within our cell component. So now that gives us a way of being able to say, well, actually, okay, I can go and check and see, well, what is the code that is causing this this thing to happen? Because the other way you can see this is if you zoom all the way down here, zoom in, you get your method names of what's being called, and then it's all these little blue boxes at the end is the parse HTML. So you can see if we can speed those up, we're going to speed everything up. And that's exactly what we were able to do. If I load another profile. God. Oh, that's saving it. Sorry. Wrong one. This one. So after the change, and I'll show you the code that we actually changed, you can see things have really improved. And we've lost that method from this chart. So we can see, okay, we've done a good job. We've managed to identify what the slowest part is, and we managed to get rid of it. And this was the code change. We just simply changed from setting something from inner HTML to text content. Because when we weren't in React, we were managing these things ourselves. So inner HTML, just for a bit of context, it can accept like a string which contains HTML elements in it. So there's added overhead here of it checking what that string is, matching things and saying, do I need to parse it and turn it into some DOM elements? So if you're just setting text itself, it's much quicker to just use text content because the browser is like, well, this is just a string. I'm just going to display it. And so in doing that, we got some massive performance improvements within the grid. Another thing, which I guess is another area of performance that you might be interested in debugging, is if you see these big purple bars in your performance profile. So this one is called recalculating styles. And so just the bar being there is quite disconnected from what actually caused the browser to have to recalculate. So you don't get this big blue arrow. This is me just trying to make it possible for you to see it because it's here, but it's very thin. But what it will do is it will draw an arrow back to the code which has changed the DOM in such a way or made a request for like a container height that has then forced the browser to have to redraw all the layouts. So as an example, where we had this issue in our grid, so new rows were added to the viewport while we were scrolling, while we were changing the sort, we had some animations. So rows were being animated out. And now to do that in a nice way, we were adding rows, destroying rows, and then the animation would query the container height so that it could animate these rows just off the screen. Because you don't want them flying out too fast. You want a kind of consistent speed with which they are, I guess, animated out. But the problem is we were then asking what the viewport height was after we had changed the DOM structure. So because we'd changed the DOM structure, the browser goes, well, I don't know what you've changed. I need to force layout so that I can give you an accurate value. So the changes in 1 and 1 were actually invalidating the height value. So when we read it in 3, the browser was forced to recalculate styles. So the fix for this particular use case was that we'd add new rows, the old rows were destroyed and we'd set up the animation, but critically, we would use a cached value of the container height. Because it's not critical that we knew exactly to the pixel what the container height was for. So by taking this approximate value, we don't have to force the browser to relay out everything. And we're still getting the same effect without forcing the layouts. So this is all about layout thrashing, if you want to dive into this topic more. Right, I think I've got time. Oh, the timer's not working. Quick fire hints. So these are some of the things which I've learned day to day, which you might find useful. Does anyone use NX here? Not that many. If you use NX in a monorepo type setup, you can give it this NX_profile, run your command, and then you can upload that to DevTools again. And that will give you a timeline of all your jobs. So if you have a complicated build chain with lots of dependent tasks, this is a nice way of visualizing that. And it can tell you, okay, this is the thing that I need to be able to optimize. So say here, we've got this long one here. So that's just a node task. Can we actually dive into that and profile that? And the answer is you can. So if you run the node task directly with this -- inspect break, and give it the task that you want to do, and then go to Chrome //inspect. There's a dedicated DevTools for node processes here. So this is an example of what we would do here. So I'm going to start the task with this inspect breakpoint. I go to my Chrome on that URL, and I can open up the dedicated DevTools. So I'll get a breakpoint here where it's waiting for me. I can go to the performance panel, start recording, and then I've hit F8 so that the task can carry on. I'll go back to my IDE, so the task is done here. Let's go back, stop the performance profile, and then we can use the same techniques and same skills that we've learned previously to now profile this node task. And so I can dive in and see, okay, where is it in this task that I need to improve? And then once you've got some fast performance, you might want to keep validating that you don't break it. So there's benchmark tests that you can do in V-test. And also I'm interested in the talk later saying, can AI help our performance testing? So if you're also interested in that, maybe go and see that talk as well. Another thing is it's possible to performance profile or have benchmark tests for your TypeScript types. So this is something which I did for AGrid as well. We had a complicated recursive type so that if you tell us what shape your row data is, we can tell you all the possible field names. And some of these field names can be nested with dots, so you can drill down into these deep objects. And so it's really nice to give auto-completion for all of that. But that can be an expensive type. So I use this library, archetype test, and set up a test, and it told me how many instantiations were done while doing this. So, that maybe isn't something we all need to worry about, but it's good to know that these tools exist. And also, if you're not familiar with the web.dev site, this is just a treasure trove of articles and information. So if you want to learn more about these things, go to this URL and just start reading. This is from the Chrome team, Google team, and there's a lot of good information in there. And finally, we've still got our good old friend, console.log, for when you want to try something a little bit simpler. Thank you very much.